Where's my blackboard? There it is. Okay. Okay, guys. There are 6 types of chemical reactions. Are you ready? Are you listening? So on the last notes, you took notes about 5 of them, and we're going to add the 6th one and the final one today. First off, I just want to preface this by saying, do you think there's only 6 kinds of reactions in the whole wide world? No, there's more than 6 different types. We will be learning about 6, but there are of course other types too. So, look at your notes. You with me, Brayden? Brayden, you with me? So, look at your notes. I want you to tell me what are the types that we have already. What? Not hydrothermic. And oh, you're right. There are those types. Those are like the 2 types regarding energy. I'm looking for the types regarding like what the chemicals do. Single replacement is one. Synthesis. What else? What else? That's 3. Decomposition. And combustion. Which, by the way, technically is called complete combustion. Doesn't probably matter, but you might see that written somewhere. Okay? These are the first 5. Okay? These video notes are on day 63 of Canvas. Okay? Now listen carefully. You didn't take these notes. You need to take these notes. Okay? So I am not going to re-give you these notes. And if you ask me a question about stuff that's written in those notes, I'm going to say, go back and watch the video notes. Because unless you obviously have a legit question and can show me where it is in your notes and say, why is this, right? You need to take those notes, okay? So go back and do those if you didn't yet. But you can start today and listen here because we're going to start the 6th one today. The 6th type of reaction that we're going to learn about is called acid-base. And sometimes it's called acid-base or neutralization. Like sometimes it might be called neutralization all by itself, or it might be called acid-base neutralization, or it might just be called acid-base, okay? But all of those would be good terms for that, okay? Now, technically, this is actually a special type of double replacement. All right, so if I were to show you a reaction like this with the knowledge that you have from your video notes on day 63, you would actually look at it and say, oh, that's a double replacement reaction. And you would be right, okay? But if you look at a high school kid and you say, ooh, look, there's a high school kid. There's ways to be more specific than that, right? You can look at a high school kid and go, ooh, look, there's a sophomore. Same idea, okay? So I'm going to give you an example of it, and then we'll kind of talk about its parts. All right. So first of all, let's talk about, I'll just write that down. All right. So first of all, let's talk about how this is a double replacement reaction. Sodium there, OH there. There's also a hydrogen and an oxygen in there. There's a hydrogen here and a second hydrogen there. and a chlorine and a chlorine. So do you see here how the sodium was with the hydroxide right here, but that it became with the chlorine, they switched partners? Do you see that? Okay. So it's really just a double replacement reaction, nothing fancy there. However, it's very, very special kind because all things that have the OH hydroxide, that means that it's a base. Okay? Now, technically, I'll just let you know this. Technically, there are some different definitions of acids and bases that chemists use in different situations. But this is the definition that we'll be using here. Anytime you see something that has an OH on it, you'll know that it's a base. Sound good? Nice and easy, right? And then this one, anybody know what this is? You should. Hydrochloric acid. Anything that starts with an H is an acid. Okay? Always. And like I said, there's technically some different definitions of acids that you could use, but we're not going to use those other ones. So these are the easy ones. Don't worry about them. Okay? So really it's double replacement, but do you notice that it starts out with an acid and a base, right? And then what's this? Water. And then you can kind of see that right here, the leftover parts are stuck back together to form something that we call a salt. Okay. And in this case, it actually is what you think of as salt. But in chemistry, the word salt just means any ionic compound. Okay. Sound good? Good. So what you should look for is that an acid and a base react to form a salt, which just means an ionic compound, and water. Okay? That is what you will always notice about acid-base reactions. Always, always, always. The other thing that maybe I should add in up here is that probably always, maybe not always, but usually, okay, this here will be aqueous, and so will this. Acids typically always are aqueous just because of some properties about them that we'll not worry about too much. And so let me ask you a trick question. Are you ready? Is this one going to be aqueous or not? How do you know that this one's going to be aqueous? It's not always mixed with water. What's that in your salt shaker at home, right?
Well, I mean, the aqueous is when it does dissolve in water.
It what?
Aqueous is when it does dissolve, like if it is put in water.
Right. Water, right. But how do you know that this one's going to be aqueous? I'll give you a hint. You ready? The whole thing was mixed with water in the first place, right? Do you see that? Those waters that they were mixed with, like they weren't important for the reaction, but they didn't just disappear, right? So the fact that it starts out being aqueous means that this one has to be aqueous too. Does that make sense? And then what about this one? Can you have aqueous water? What does aqueous mean? Dissolved in water. So does it even make any sense to have aqueous water? That's like saying, can I have some macaroni and cheese mixed with my macaroni and cheese? Right? It's just silly. So this one is just a liquid. Make sense? There's one more small thing that I want to add on here, which is about the pH scale. And the pH scale actually is written like this with a lowercase p and a capital H. And the reason is that we're actually measuring the concentration of hydrogen ions. Okay? Now, I could get all complicated on you right now and go crazy math whiz on you right now and explain how the numbers of pH correspond to how much hydrogen is in there, but I'm not going to do that. Just trust me, it's mathematical. Does that sound like a good deal? Okay. An acid is a low pH. 1 is the lowest it can go. Okay. Neutral equals 7. So that's in the middle. And a base is a high pH. And 14 is the highest it can go. Sound good? And if you really want to know the math behind those numbers, I'll explain it to you, but not to the whole class, because I'll probably just confuse somebody. Sound good? Is that manageable? There you go. That's the end of the notes.